Point of intersection. Graph the following linear relations on the same axes to determine their point of intersection. The first relation is y equals x minus 2. The second, y equals negative 2x plus 1. The first thing we have to understand is what exactly is a point of intersection. And the point of intersection is the ordered pair where two or more relations intersect or cross. In order to figure out the point where the two of them cross, we need to create a graph. And when we're given an equation that represents a relationship, a table of values can be used to create a set of ordered pairs that can be plotted on the Cartesian plane to represent the relationship. So the first thing we're going to do is create a table of values, and then we need to choose values for the independent variable x. So the easiest values are numbers like -2, -1, 0, 1, and 2. And then we have to substitute those values into the formula to solve for the dependent variable y. So for example, y equals -2x plus 1. We're going to pick all our x values to be -2, -1, 0, 1, and 2. And we're going to substitute into the equation. So y equals -2 times -2 plus 1, which is 4 plus 1, which gives us a y value of 5. And we have the ordered pair -2, 5. So for y equals -1, again, -2 multiplied by -1 plus 1 is +2 plus 1, which gives us the ordered pair -1, 3. Y equals -2 times 0 plus 1, which is 0 plus 1, which gives us the ordered pair 0, 1. Now we need to have at least 3 points in our table of values in order to ensure that we've graphed our line correctly. We're going to add a couple more just for a bit of practice. 2 times 1 plus 1 is 2 plus 1, and that gives us the ordered pair 1. Oops, I forgot the negative sign. -2 times -1, which is -2 plus 1, so the ordered pair is 1, -1. And finally, -2 times 2 plus 1, which is -4 plus 1, and that gives us the ordered pair 2, -3. So now we can take our points and plot them on the Cartesian plane. So -2, 5, we are going to start at the origin. We go left 2 and up 5, and we plot our point. -1, 3, we start at the origin. We go left 1 and up 3 and plot our point. 0, 1, we stay on the y-axis and we move up 1. 1, -1, I start at the origin. I go right 1 and down 1. And 2, -3, again, I start at the origin, go right 2 and down 3. And then I can drag my line, and I'm going to twist it around to make sure it goes through all of my points. And finally, in order to ensure accuracy, in order to have proper formatting on my line, of course my points aren't perfect because it is difficult to maneuver here, I do need to draw arrows on either end of the line. Now, for the second, and I also have to label it y equals -2x plus 1. For the second equation, y equals x minus 2, I can use the slope and y-intercept. The y-intercept is 0, -2. And the slope is 1x because there's a 1 in front of the x. And that means the rise is 1 when the run is 1. So I can start at the point 0, -2 and go up 1 and right 1. And I can grab my line and draw a straight line through. And again, I need arrows and I need to label it. Now, what do I notice about both of these relationships? I can say that y equals -2x plus 1 is a perfect negative correlation, okay, because it's a straight line and the slope is negative. It's also a partial variation because it rises to the left. And it's a partial variation because the y-intercept is not 0. It's a negative correlation because it rises to the left. Now the blue line is also a partial variation because the y-intercept is not 0, but it's a perfect positive correlation because it's a straight line through all the points that rises to the right. Finally, we can say that the point of intersection here is at 1, -1, because this is the point where the two equations cross one another on the graph.